Hello everyone, this is Shubham Chaudhary and I welcome you again in the new video of our YouTube channel. So this is the LeetCode medium problem which was asked on 23rd of February. So this is cheapest flights within K stops. Here there are n cities connected by some number of flights and we have given an array flights where flights of I equals to from to price indicates that there is a flight from I to city to I with cost of price I, and they have given also three integers source, destination and k. We need to return the cheapest price from source to destination with at most k stops, and if there is no such route then return -1. So in this example 1 there are n equals to 4. What is n? N is the 4 cities, so there are n 4 cities and flights are scheduled according to this. So 0 and 1 means from this to this and price of that. So 0 to 1 it will cost 100. From 1 to 2 it will cost 100. 2 to 0 it will cost 100. This is the image we are saying, visual representation of the array. Then 1 to 3 equals to 600 cost, then 2 to 3 it costs 200, and we need to calculate the cheapest price from 0 to 3, source 0 to destination 3 with maximum of k equals to 1 stops. So our output will be 700. How? Let's see. So the graph is shown. The optimal path with at most one stop from city 0 to 3 is marked in red and has cost of this. So this red marked way is a optimal path. So 100 plus 600 equals to 700. And note that the path through cities is cheaper but is invalid because it uses two stops. So 0, 1, 2, 3. 0, 1, 2, 3. It is cheapest, but we need to calculate we need to think at most one stop. So it will, here they have used two stops, that's why it is an invalid solution. In the example second, there are n cities and flights are scheduled accordingly to the array. Then source is 0 and destination is 2 and k equals to 1 stops. So the optimal answer cheapest price will be 200 from 0, 1 to 2. In the example 3, source is 0, destination is 2 and k equals to 0. So 0 set 2. So there it will be only 500. The optimal path with no stops from city 0 to 2 is marked in red. That's one. So how to approach this type of problem? Let's see. So we need to construct an adjacency list to represent the graph using an unordered map where each vertex is mapped to a list of its neighboring vertices along with the corresponding flight prices. So we will calculate an adjacency list to represent the graph using an unordered map. Then after that we will initialize a vector dist of size n to store minimum distances from the source vertex to all other vertices, and initialize all the distances to infinity except for the source vertex which is set to 0. Now we will create a queue to perform depth first search traversal of the graph. After that we will enqueue the source vertex along with its distance initialized to 0 into the queue. After that we will initialize a variable stops to track the number of stops made during the traversal. Then perform breadth first search traversal until the queue becomes empty or the number of stops exceed k. Inside the traversal loop, process each vertex and its distance from the source. For each vertex, iterate through its neighbors and update their distances if a shorter path is found. And enqueue the updated neighbor vertices into the queue for further exploration. Then increment the stops counter after processing each level in the breadth first traversal. And after the traversal, return the minimum distance of the destination vertex from the distance vector, and if the distance is still infinity, we return -1, and indicating that there is no valid path from the source to the destination within k stops. So this is the overall approach. Let's see what will be the code. For better understanding of the approach, read the approach once again, and after that follow the code and check how the code is getting from this approach. So before that, if you are new to the channel, hit the like button and subscribe for more content. So let's declare an unordered map first of int comma vector of pair of int comma int adjacent map. This is a vector. This is an unordered map. So key is int and value is a vector. After that, we will populate this using for loop for auto ampersand flag in flags. We will do what? We will do adjacent of flight of 0, and we will push back flight of 1 comma flight of 2. Means we are pushing back in the adjacent unordered map, as because of this it is a vector. We will insert in the form of vector here. After populating this map, we will create a vector int dist of size n and value int max and a distance of src equals to 0. So after that, we will implement a queue of pair. Then we will push src comma 0 into the queue in the form of pair. Then we will initialize stops variable equal to 0. After that, we will implement a while loop. So while queue dot empty and stops less than equal to k. We will do what? We will create a new variable as I said. Let's call it, and it will take the value of q dot size, and while I said tends to 0, we will perform auto node distance equals to q dot front. So we are creating two variables, node and distance, and then again we will pop out this thing. After that, we will check if adjacent dot count of node is false. If so, then we will continue, and we will use for loop, nested for loop, or auto ampersand neighbor comma price in adjacency of in adds of node, and if price plus distance is greater than equal to distance of neighbor then we will continue, and if distance, and here we will update distance of neighbor equal to price plus distance, and at last we will push q dot push neighbor and dist of neighbor. Neighbor and dist of neighbor. And after this, inside of this value we will increment stops plus plus, and at last it will return dist of dst equals to int max if it is int max, and if it is true then we will return -1, else we will return dist of dst distance. So this is the code based on this approach. If you want to have more clarity, then again go through this approach as well as this code parallelly, you will get the solution. Let's run this code. So expected qualification qualified ID. So there was a syntax error here. We need to decrement as said and then check greater than if it is greater than 0 or not. Why is it taking so much time? Let's copy this, refresh the page. So okay, let's run this again. Yeah, the test cases ran successfully. Check for the hidden test cases. Yeah, the solution is right. Here the time complexity will be big O of v plus e, because v is the vertices and e is the number of edges. So overall time complexity will be big O of v plus e, and the space complexity will also be big O of v plus e. So that's it. If you enjoyed the video or found it helpful, don't forget to hit the like button and subscribe for more content. Your feedback is crucial, so give feedback if any, and stay tuned for upcoming LeetCode problem of the day videos and exciting one-step web development projects. Happy coding, and let's make this year a fantastic one together. Thank you.